Hello everyone. Today I am going to discuss the second problem of Leetcode Weekly Contest 440, which is choose k element with maximum sum. So what is the problem? We are given two integer arrays nums1 and nums2, both of length 10, and another positive integer k. So for a particular index I, what we have to do, find all index j such that the nums1 j, that means in the first array only, nums1 j is less than nums1 I, and for all the found indexes j, we have to choose at most k values at these indices to maximize the total sum. And for every index I, we have to find the sum value, total sum value. So let's take the first example only. 4, 2, 1, 5, 3, and nums2 is 10, 20, 30, 40, 50. Now for I equals to 0, the value is 4. So, what are the possible j values? The j values could be 1, first index, because it is less than 4, the second index 1 because it is also less than 4, or the fourth index 3 which is also less than 4. So, from the first, second, and fourth index, we have to take at most two values. So, 20, 30, and 50, we have to take at most two values to maximize the sum. So, we will take the 50 value and the 30 value. So, the second index and the fourth index. So 50 plus 30 will be 80. So like that, we will do this for every possible index. Let's take the for the second index 1. We For the second index, there is no value which is less than this value 1. Okay, so the answer will be 0 there. Okay, I hope you get it. Now how we are going to solve this problem? Okay, so that is the important part. So before that, let's discuss the possible time complexity. Here n is 10 to the power 5. Okay, so here n is 10 to the power 5. So possible time complexity could be either order of n or order of n log n or order of n log square n also. I have solved this problem in order of n log n. Now I will discuss the solution approach and okay. So let's discuss the solution approach. Okay. Let me take some moment to iterate through my solution. And so I have gone through my solution, and I have forgotten to mention one edge case, the nums one is 2222. Here you can see that there is no value which is greater than less than 2. Okay, so for every index the answer will be 0. That is one edge case we have to keep in mind, because my solution approach will also have that thing. Okay, so here you can see that nums one is not sorted. Okay, so we have to sort. We will sort this value of nums1. Okay. Now how will we sort this array? If let's say if we sort only the value of nums1, we will lose the indexing of this, and we will not be able to map some nums1 I to nums2 I. Okay. So for that we will make another vector which will have nums1 I. Let's call it nums1 I, num1 I, and I. So the another array will contain this pair. After forming the array with these pairs, we'll sort this array. Okay, in ascending order. We'll sort this array in the ascending order, and we'll iterate over this array. We'll iterate over this array. Let's say we have some index I at this array. That means that we have already taken all the values less than equals to this. We have already taken all the values less than equals to this. We'll also maintain one set. Okay, a set S. Okay, we'll also maintain a set S, which will uh, have at most k values, and which is less than equals to I. So what I am saying is that we are iterating over this sorted array, and we are at index I. Then I minus 1, I minus 2 till index 0. We'll have nums1 j as less than nums1 I. Okay. So now we will iterate over all those values, and we will add nums2 j for those values. Okay. So set will contains nums2 j num2j for j less than equals to j less than I. Okay, j less than I. Now if we take the sum of all the values in the set, because S will contain only at most k elements, if we take the sum of all the elements in the S, which will give us the answer value for the current index I. Okay, I hope you get it. Now there is the edge case I have mentioned, that there could be 2222. Okay, 2222, and let's say there is another value 6 here. Okay, now when we will add all these values 6, let's say this is 10, this is 5, this is 15, this is 20. Let's say, okay, now we what I am saying is that after uh, going from I to I plus 1, we have to add this nums to I value in the set S. But if we add this nums to I value in the set S, this will again be considered for this two, right? Because for this two will check in the set what are the values and will take the sum. So if we add 10 after iterating this element, we'll add 10 to 10 for the answer for this two, okay, which is not the correct one, okay. So for that there is one thing we have to do. We have to add all these 10, 5, 15, 20 value after iterating this two. So this is another case we have to keep in mind, okay. Now let's go to the code. You will understand it better, okay. Now uh, this is the set b which a vector b which I am forming with nums1 I and I, and after that I am sorting the vector, okay, b, and we are iterating over the vector. Initially sum is initialized to 0, and at the start we will have the sum in the set. Sum is means the sum of all the elements in the set, okay. Now answer of bi1 is equals to sum. At the start we are assigning sum to the, this bi1 is the index I, because we have set bi1 as I. So answer of bi1 is sum. Now if I plus 1 equals to n, and bi or bi plus 1 0 not equals to bi 0, that means for this two, for this two, this second condition will not satisfy, because bi plus 1 0 will be bi 0. So this condition will not satisfy, okay. So we'll not enter this loop. Let's say for the last b value we have entered this loop, okay. I plus 1 is not equals to n, and bi plus 1 is not equals to bi 0. Now we are initialize j with I, and while j greater than equals to 0, so j is initialized with this value, and while j greater than equals to 0, then let's say 1 is here, okay, 1, and let's say 25 is here, okay. So while j greater than equals to 0 and bi 0 equals to bj 0, so we'll change the value of j, and I will be fixed to this point, okay. Now we'll compare bj 0 and bi 0. If these are equal, we'll add the nums to j value in the set, and sum plus equals to nums to j, okay. Now if a dot size is greater than k, that means the number of elements in the set is greater than k, then we have to erase the minimum element from the set, because we have to take the maximum element sum. We have to erase the minimum element from the set, and which is the first element of the set, and erase it from the set, and delete it from sum, okay. I hope you get it. Now there are two cases we have to keep in mind. There are two more edge cases. Not two more edge cases. One edge case is important. Thing is that we can't use set, because set has unique elements. Okay, so set has unique elements. Let's say this value is also 15. Then this 15 will be added only once. So for that we have to use multi-set, because multi-set could have similar elements, okay, same elements. So we have to use multi-set. Now another thing which is not there in the problem, what if nums to j is less than 0? This is the follow-up problem, you can say. If the nums to j is greater than 0, nums to j is less than 0, then we can't really solve this, right? uh, because if, let's say this is minus 25, everything is minus, okay, then our answer will be 0. So in that case we have to solve this problem differently. I have not thought about how to solve this problem. You can try this problem as a follow-up problem. uh, I think you will understand the code and the explanation. If you have any doubt in any part of the code or explanation, you can always ask in the comment section. I'll try to reply each and every comment. If you find this video helpful, please like the video, subscribe to the channel, and also share among your peers. Thank you.